We looked at these formulas yesterday, and we talked about a cylinder being a circle on the bottom multiplied by its height, and if you kept stacking circles on top of each other, you'd fill that whole shape. And so that's the volume for a cylinder. And the same idea with the 1/3 for the volume of a pyramid with a square base or any base happens with a cone. It's just 1/3 the area of the cone. So imagine you were given this cone to make an ice cream cone. Look how big it is. It's 13 millimeters high and has a diameter of 8 millimeters. This is going to be the most delectable, tiny little ice cream cone you've ever made. And if you made an ice cream cone, one of the things that I like to make sure happens, especially with hard ice cream, is trying to get as much ice cream inside the cone before, because otherwise it's sort of like you finish the ice cream on the top and you're like, oh, now I just got the cone. So you try and get as much ice cream inside. So we're going to try to figure out the volume of this cone to see how much ice cream we could fit inside of it. Now our volume formula for a cone, and it's a good idea whenever you're working with formulas to write out the formula first and then take the time to fill things in. I want to find my volume. I know my height is 13, and it's not my slant height this time. I have to be careful here because sometimes people are tempted to put 8 in here. Why can't I put 8 in there? It's my diameter. So how do I find my radius if I know my diameter? Cut it in half. So this will be 4 squared, and then my height is 13. I can go to my calculator and type all of these things in at once. 1 divided by 3 times pi, bracket 4, squared, bracket 13, push enter, 217.8. Did the question ask me to round to something? Yes, to the nearest cubic millimeter. So this will become 218 millimeters cubed. How much ice cream is that? Well, first of all, let's imagine how big a millimeter cubed is. Can you visualize without touching that as a millimeter? Okay, and then another one this way, and another one high. And so we got something about that big. We have 218 of those. Is this easy to visualize? No. How much would this be in centimeters cubed? Okay? The first thing you want to do is you want to just divide by 10. 21.8. Because you know that there are 10 millimeters in 1 centimeter. Okay? But it's not true that there are 10 millimeters cubed in 1 centimeter cubed. And part of it is, you know when I did 1 meter by 1 meter and said how many centimeters squared are in a 1 meter squared? And there was more than the 100 because there'd be 100 this way and 100 this way. So there ended up being 10,000, no, yes, 10,000 centimeters squared in 1 meter squared. So if we imagine a centimeter, and I'll draw it a little bit bigger than a normal centimeter, and another centimeter here, and I make a square, in 1 centimeter squared, well, there would be 10 this way and 10 this way, there would be 100 millimeters squared in a centimeter squared. Can you visualize that? That if I drew dots all the way along here, it would take me 100 of them to fill the whole thing up. When I get to a centimeter cubed, well, that 100 would only fill up the first row of it. And you would need another 100 for the second row, the third row, all the way to the 10th column or row. And so when you get to 1 centimeter cubed, you would need 1,000 millimeters cubed. So if I'm converting 218 millimeters cubed to centimeters cubed, I don't divide by 10, I have to divide by 1,000. Now a centimeter cubed is a little bit easier to visualize than a millimeter cube because it's a little bit bigger. You can actually draw it out to be about a cube that's about that big. Still not very big. And you only have 0.2 of that. So you don't have very much at all. This would be like the most disappointing ice cream cone ever because there's so little ice cream in it. Since we're doing conversions, did you know that 1 centimeter cubed is equal to 1 milliliter?
Because the metric system is great.
The metric system is great. And sometimes if you've got sometimes if you go for your shots that you have to get, like do you have to get shots in grade 9? Or is it grade 8? Where they give you mandatory shots and everybody is so excited.
Shots?
Like needles.
Oh, you get a set of that.
I'm kidding. It's called, sorry, I'll teach you some English. Sarcasm. So, but something connected to that, often on needles, they'll say, we're going to give you 10 cc's of this medication on a needle. The cc, when they talk about that, is really cubic centimeters. And what they're actually giving you is 10 milliliters of that substance.
Then why not just say?
I don't know, maybe it's quicker to say cc than ml? I don't know. Sounds cooler? I'm not sure. But there's some more conversion stuff connected to our volumes and things that we figured out. But to just ask for the nearest cubic millimeter, all that we found out is that this is very, very little ice cream. And you should order a bigger size next time. A cone has a height of 8 meters and a volume of 300 meters cubed. This is my kind of ice cream cone. Okay? You know how big a meter cubed is? Okay? It has 300 of those inside of your cone. It might be all the ice cream you'll ever need for your entire lifetime. Determine the radius and base of the cone, of the base of the cone to the nearest meter. Sketch and label a diagram. So, I want to find the radius, so this is what I don't know. I know that it has a height of 8 meters, and I know that the volume is equal to 300 meters cubed. So my volume formula for a cone is 1/3 pi r squared times height. And I know the volume is 300. I don't know my radius, but I know that my height is 8. So I need to solve for that radius to the nearest meter. There's my radius, and it's being squared. All the other numbers there need to be removed from that side of the equation onto the other side of the equation so I can get that r squared by itself. What would you suggest we do first? We could divide by 8. Because on this side, do you see we're multiplying by 8? So if I divide both sides by 8, that will simplify this because 8 divided by 8 is 1. And now on this side, I'm just left with 1/3 pi and r squared. And on this side, we're left with 37.5. Okay, closer. We moved the 8 over. What could I do next? Multiply it by 3. Why would you want to multiply it by 3? To get rid of the fraction. Because a fraction 1 divided by 3 is actually dividing by 3. The opposite of dividing by 3 would be to multiply this side by 3, and then I need to multiply this side by 3. That will cancel out my 1/3. And 37.5 times 3 is 112.5. Now we have pi r squared. How do we get rid of the pi? Divide by pi. So now we're multiplying by pi. We divide by pi. For sure now, we need to go to our calculator. 112.5 divide by, and we don't use 3.14, we use the exact answer, get 35.8. How do we get rid of something squared?
Square root.
Take the square root. Now, something that's going to come up over and over again in your math is there's a rule when you take the square root of both sides. And it's not really taught to you very well because the first time you have to do square roots of both sides, you're dealing with a squared plus b squared equals c squared. Okay? It's one of the first places that you're dealing with squareds, and you're finding the length of a hypotenuse. And then we get to questions like this where you're finding the length of the radius, and most people just do this as their answer. They go to their calculator, they go square root. On your calculators, if you have this calculator, above the negative sign is the answer button, so you can go second, answer, and it just retypes the answer that you had from before, which is really nice. Push enter, and we find out the square root is 5.98. And it says round to the nearest meter. Did it? So you get 6. Nice. Which makes sense, because 35.8 is really close to 36, and the square root of 36 is 6. Now, in this question, this is the right answer. We should write out, we would lose a half a mark here because we didn't add our units. I'll write a sentence. Our units were meters, so our radius is 6 meters. Okay? Later on in mathematics, you might lose a half a mark in this question because if something squared is 9, and you square root both sides, what do you get? 3. Is that the only answer? Could also be -3, right? Because -3 times -3 is also +9. So the rule in mathematics is whenever you take the square root of both sides, we show that it could be positive or negative. So in our question, technically at this point when we take the square root of both sides, we should write that the radius could be plus or minus 6. However, since we're dealing with a real life problem here, one of those answers, the -6, actually doesn't make sense. You can't have a radius of -6 meters. So the only answer is the positive one. But if this was a question that was just saying, solve the algebra, there are 2 possible answers. It could be -6, because -6 times -6 is close to +36, or is 36. or it could be positive 6. Yes?
Can we still put the plus or minus in the equation and then just say the radius is 6 meters?
This would be the best mathematical would be to have the plus or minus in the equation to show that you've done the math all the way through, and then you realize that there is only one answer that makes sense. Technically, the same is true when you do a squared plus b squared equals c squared, but the hypotenuse, which is a length, doesn't make sense to write as minus 10 or something like that. So we always get used to writing the positive ones, and we set ourselves up for later on in math to forget the plus or minus over and over and over again, because we have a whole bunch of real life situations we do first where we ignore it. Yes?
So if we lose a mark in an obvious quote-unquote situation where we put plus and minus, so like for the hypotenuse again.
If you did plus or minus and left it like that to say that those are both the answers even though only one makes sense, yes.
You would lose one.
Because you need to say that only the positive 6 makes sense here. Okay? So in that situation. And in those situations where only the positive one makes sense, generally you don't lose. Like in this question, if you didn't put the plus or minus, you just went 6, because the situation demands that only we have a positive answer, the marking guide on your final exam wouldn't deduct for not forgetting the plus or minus. Okay? But if we want to start training ourselves to be really good with all the details, it is better to put the plus or minus to show I know it could be both, and then to put in our statement, but in this situation it's only the positive one.